So next reaction is reaction with arene sulfonyl chloride. Reaction with arene sulfonyl chloride. Okay. So what is arene sulfonyl chloride? Arene means benzene ring or aryl group. Okay. So this is arene ring. So arene ring means here double bond, double bond, double bond. Okay. So arene sulfonyl means yes double bond O, yes double bond O, bond Cl, bond Cl. This is known as benzene sulfonyl chloride. Name of this compound is benzene sulfonyl chloride. Benzene sulfonyl chloride. This benzene sulfonyl chloride reacts with primary amine. So let us take here primary amine as C2H5NH2, C2H5NH2, and this nitrogen carries lone pair of electron. Nitrogen carries lone pair of electron. Now this chlorine carries delta minus charge and sulfur carries delta plus charge. So this lone pair on nitrogen attacks on sulfur, attacks on sulfur. Simultaneously, this sulfur chlorine bond is ruptured and hydrogen and chlorine combines with each other. Hydrogen and chlorine combines with each other to give HCl as a byproduct. HCl as a byproduct. Okay. So here double bond, double bond, double bond. Here S double bond O, double bond O. Here nitrogen is attached to the sulfur. Nitrogen is now attached to C2H5 and one hydrogen atom plus HCl is the byproduct. HCl is the byproduct. So name of this compound is N-ethyl benzene sulfonamide. N-ethyl benzene sulfonamide. So name is N-ethyl benzene sulfonamide. N-ethyl benzene sulfonamide. This is the name for the compound. Okay. So in this reaction, hydrogen and chlorine combines with each other and nitrogen gets attached to the sulfur. This sulfur is electron deficient because it is attached to 1, 2 and 3 electron withdrawing groups. So these groups withdraws electron density from sulfur and makes the sulfur electron deficient, so nitrogen attacks on the sulfur, because nitrogen is electron rich, okay. So this is our major formed product and this is HCl is minor product. So let us take one more example. In that example, benzene sulfonyl chloride remains as it is, but we have to change here primary amine. Instead of taking primary amine, we have to take secondary amine. So this is benzene. Benzene is attached to sulfur. Yes, double bond O, yes, double bond O. Benzene sulfonyl chloride plus it is attached to nitrogen C2H5 and C2H5. So in this reaction, NH is present, so it is secondary amine. So this nitrogen attacks on this sulfur. This hydrogen and chlorine gives byproduct HCl. So I will write here the name of byproduct HCl. Now major product, this is benzene ring. Okay, to this benzene ring sulfur, to this sulfur double bond oxygen, to this sulfur again nitrogen, to this nitrogen C2H5, to this nitrogen C2H5. H5. So this is the major product and HCl is the minor product. So name of this compound is NN diethyl. Name is NN diethyl benzene sulfonamide. Benzene sulfonamide. Benzene sulfonamide. So let me explain the name of this compound. NN diethyl means diethyl group, ethyl group, ethyl group. Two ethyl groups are attached to the nitrogen. So NN diethyl. Benzene means this aromatic ring, and sulfonamide means SO2 N, SO2 N. Okay, so we know amide. Amide means CONH2. So sulfonamide means sulfur is present. So it is known as sulfonamide. Sulfonamide. Okay, so very simple reaction. H from primary and secondary amine reacts with chlorine. So HCl is the byproduct and sulfur and nitrogen are linked together due to the nucleophilic attack of nitrogen. Nucleophilic attack of nitrogen. So this is the reaction of aryl sulfonine chloride. This reaction is also known as arene sulfonyl or aryl sulfonyl. Both are correct. Okay. So now let us move towards next type of reaction, electrophilic aromatic substitution reactions. So this is reaction number 9, electrophilic aromatic substitution. Electrophilic aromatic substitution reactions. Okay, so generally substitution reaction takes place in aromatic compounds. So let us consider primary aromatic amine. So primary aromatic amine means benzene ring, and benzene ring means aromatic group, and to this aromatic benzene ring NH2 is attached. NH2 is attached. This nitrogen carries lone pair of electron. Okay, so name of this compound is aniline. This aniline reacts with bromine. Aniline reacts with bromine. Bromine means Br2. Okay, so this Br2 is taken as bromine water. Bromine water. Okay, so what happens here? This bromine Br2 means Br bond Br undergoes heterolytic fission. Undergoes heterolytic fission means breaking of this bond takes place heterolytically, means after breaking of bond only one bromine gets two electrons. So the bromine which loses electron carries positive charge, the bromine which gets electron is negatively charged. Okay, so three bromines are taken, so here 3Br plus 3Br minus is produced. So this Br plus is known as electrophile. This is known as electrophile. So what is electrophile? Electrophiles are electron deficient species. Electron deficient species, and it carries positive charge. Now we know that in aniline this NH2 is electron donating group. So it donates electron density towards the benzene ring. Okay, and due to this electron donation, this ortho position, okay, this is ortho position, this para position, and this also ortho position, this three position becomes electron rich. So at these three positions 3Br plus gets attached, and initially here hydrogen atoms are present, so that hydrogen is replaced by bromine, means here one hydrogen is present, here also hydrogen present, here also hydrogen present. From these three positions, three hydrogens are replaced and three bromines are attached to that positions. So double bond, double bond, double bond, here NH2, in this position bromine, this position bromine, to this position bromine is attached. Okay, now three hydrogen atoms are removed, that three hydrogen and these three bromines gives 3 HBr as the minor product. 3 HBr as the minor product. So this is functional group NH2, 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5, 6. Okay, so name is 2, comma 4, comma 6, means at second position, at fourth position, and at sixth position. Three bromine groups are attached. 2, comma 4, comma 6, tribromo. Okay, and original compound is aniline. Original compound is aniline. So name is 2,4,6 tribromoaniline. Name is 2,4,6 tribromoaniline. Means here excess of bromine is taken. Excess of bromine is taken. If excess of bromine is taken, then attack takes place at ortho and para positions. Ortho and para positions. म्हणजे याच्यामध्ये काय होणार आहे बघा, हा आपला ॲनिलिन आहे. ॲनिलिन म्हणजे काय असतं, बेन्झिन रिंगला NH2 अटॅच असतो. ओके, हा NH2 त्या नायट्रोजन वरती काय आहे, लोन पेअर ऑफ इलेक्ट्रॉन प्रेझेंट आहे. ओके, ती लोन पेअर तो काय करतो, ह्या बेंझिन रिंगशी काय करतो, शेअर करतो. कसं शेअर करतो हे आपण सगळं स्टडी केलेलं आहे. त्याला आपण काय म्हणतो, पॉझिटिव्ह इंडक्टिव्ह इफेक्ट. पॉझिटिव्ह इंडक्टिव्ह इफेक्ट. ओके, मग ही इलेक्ट्रॉन डेन्सिटी इकडे शेअर केल्यामुळं इथं ऑर्थो पोझिशनला काय येतो, निगेटिव्ह चार्ज येतो. इथं पॅरा पोझिशनला पण निगेटिव्ह चार्ज येतो आणि इथं ऑर्थो पोझिशनला पण निगेटिव्ह चार्ज येतो. मीन्स 2 ortho and 1 para position becomes electron rich. ओके, अटॅक कोण करणार आहे रे, इलेक्ट्रोफाइल. इलेक्ट्रोफाइल म्हणजे काय, इलेक्ट्रोफाइल्स आर दी इलेक्ट्रॉन डेफिशियंट स्पेसिस, आल्सो दे कॅरीज पॉझिटिव्ह चार्ज. मग अटॅक करणारा जर पॉझिटिव्हली चार्ज असेल तर तो कुठे अटॅक करणार आहे, निगेटिव्ह चार्ज वरती. इथे एक्सेस ऑफ ब्रोमिन घेतला आहे म्हणून 2 ऑर्थो आणि 1 पॅरा पोझिशन, तिन्ही पोझिशनला काय झालेलं आहे, ब्रोमिन अटॅच झालेला आहे. नेम ऑफ द कंपाऊंड इज 2,4,6 tribromoaniline. 2,4,6 tribromoaniline. This is very simple example of electrophilic aromatic substitution. Okay, this reaction is known as bromination. This reaction is known as bromination. Reaction number 1, bromination, means in this reaction bromine atom is substituted over the aniline. Substituted over the aniline. Okay, so this is bromination reaction. Now second reaction is nitration reaction. Second reaction is nitration reaction. Okay, and we know that nitration means introduction of NO2 group. Introduction of NO2 group. So second reaction is nitration of aniline. Nitration of aniline. So what is aniline? Aniline means NH2 group is attached to the benzene ring. Okay, so this is benzene ring. So to this benzene ring, NH2 is attached. Okay, now we have to carry out nitration. We have to carry out nitration. Okay, and for this purpose, for nitration purpose, we require NO2 group. We require NO2 group, and that NO2 group is produced by mixture of concentrated HNO3 and H2SO4. Mixture of concentrated HNO3 and concentrated H2SO4. Concentrated H2SO4. So both HNO3 and H2SO4 are taken as concentrated, and temperature for this reaction is 288 Kelvin. 288 Kelvin. We know that in nitration, attacking species is NO2 plus. NO2 plus. Okay, so this NO2 group is attached to the benzene ring or aniline. Okay, now this NO2 plus is prepared by or produced by HNO3 and H2SO4. HNO3 and H2SO4. Okay, so at ortho and para position negative charge is present. So this reaction gives mixture of product. This reaction gives mixture of product. Okay, so let us see which mixture is formed. This is aniline. In first, NO2 group is attached to the para position. This is formed in 51%. 51%. In second, NH2, NO2. This is 47%. 47%. Okay. Then this is NH2 and NO2. This product is formed as only 2%. Only 2%. So here mixture of ortho, meta and para is formed. So this is not proper way of getting products, because our products contains three mixture of three products. Then again we have to isolate the products, and we get product in very little quantity. So this is not an ideal route. This is not an ideal route. म्हणजे बघा, आपल्याला समजा पॅरा नायट्रो ॲनिलीन पाहिजे. आता ह्या कंपाऊंडचं नेम काय आहे? पॅरा नायट्रो ॲनिलीन. मीन्स पॅरा पोझिशनला काय नायट्रो ग्रुप अटॅच आहे. याला काय म्हणायचं? पॅरा नायट्रो ॲनिलीन. हा काय आहे? मेटा नायट्रो ॲनिलीन. हा काय आहे? ऑर्थो नायट्रो ॲनिलीन. समजा आपल्याला फक्त पॅरा नायट्रो ॲनिलीन हा प्रॉडक्ट पाहिजे आहे. मग ही रिॲक्शन काय करायला लागली? आपल्याला मिक्सचर देत आहे, म्हणजे पॅरा पण देत आहे, मेटा पण देत आहे आणि ऑर्थो पण देत आहे. मग परत मला काय करायला पाहिजे? ते पॅरा मेटा ऑर्थो सेपरेट करून फक्त पॅरा काढून घ्यायला पाहिजे. पर पॅरा किती तयार झालेला आहे? 51% तयार झालेला आहे. म्हणजे काय? 50% प्रॉडक्ट मला मिळालेला आहे. मीन्स रिॲक्टंट 2 kg वापरला तर प्रॉडक्ट काय मिळणार आहे? 1 kg. म्हणजे मला हे इकॉनॉमिकली काय नाही आहे? प्रॉफिटेबल नाही आहे. म्हणजे ही रिॲक्शन मला सुटेबल नाही आहे. आय डिसलाइक दिस वे बिकॉज वी गेट मिक्सचर अँड ऑल्सो yield इज लेस. yield इज लेस. ओके. मग त्याच्यावरती आपल्याला काय केलं पाहिजे? काहीतरी सोल्युशन काढलं पाहिजे. ओके. दॅट सोल्युशन इज नोन ॲज प्रोटेक्शन ऑफ फंक्शनल ग्रुप. प्रोटेक्शन ऑफ फंक्शनल ग्रुप. तर हे असं का झालेलं आहे? तर हा NH2 काय करतो? इलेक्ट्रॉन डेन्सिटी बेन्झिन रिंगला देतो. त्याच्यामुळे आपल्याला काय मिळतंय? मिक्सचर ऑफ प्रॉडक्ट मिळत आहे. मग आपण ह्या NH ला किंवा ह्या N ला काय करूया? एक इलेक्ट्रॉन विड्रॉइंग ग्रुप अटॅच करूया. म्हणजे तो काय करेल? इकडे इलेक्ट्रॉन डेन्सिटी आपल्याकडे पुल करेल. मग हा नायट्रोजन बेन्झिनला इलेक्ट्रॉन डेन्सिटी शिफ्ट करू शकणार नाही, म्हणजे जास्त शिफ्ट करू शकणार नाही, आणि आपण बरोबर काय करेल? पॅराला आपला अटॅक करू शकू. येथे लक्षात तुमच्या? तर चला आपण काय बघूया? प्रोटेक्शन ऑफ फंक्शनल ग्रुप. सो रिॲक्शन सेम असणार आहे. रिॲक्शन इज सेम बट देर इज लिटिल डिफरन्स. आता डिफरन्स काय आहे ते आपण बघूया. ओके. सो दिस इज our initial reactant. Name of this reactant is aniline. Name of this reactant is aniline. Now this aniline is reacted with acetic anhydride. Acetic anhydride. Acetic anhydride means CS3 CO2O. CS3 CO2O, and this reaction is carried out in presence of base pyridine. Okay. Now what is acetic anhydride? Acetic anhydride is written like this: CS3 C double bond O O C double bond O CS3. Okay. So one hydrogen atom and this CS3COO gives CS3COOH, gives CS3COOH, and in the place of that hydrogen this COCS3 is attached. This COCS3 is attached. Okay. So here this is N to this nitrogen. One hydrogen is attached, so NH, and to this nitrogen COCS3 is attached. Okay. So in this way this CO is electron withdrawing group and it withdraws this electron density from nitrogen. So name of this compound is acetanilide. Name of this compound is acetanilide. Okay. Now this acetanilide undergoes nitration reaction by using mixture of concentrated HNO3 and concentrated H2SO4, and temperature is 288 Kelvin. Temperature is 288 Kelvin. So what happens? Now NO2 attacks on only para position. NO2 attacks on only para position. Okay. So double bond, double bond, double bond. Here NH CO CS3, NHCO CS3, and this NO2 is attached on the para position. So this is acetanilide. To this acetanilide at para position NO2 is attached. So name is para nitro acetanilide. Para nitro acetanilide. Again, this para nitro acetanilide undergoes hydrolysis. Okay. So in hydrolysis means addition of water molecule, and after addition of water molecule, the molecule is splitted into two parts. Means this nitrogen gets H and this carbon gets OH. So again NH2 functional group is restored. NH2 functional group is restored. So here our NH2 functional group, here is the NO2 plus byproduct is CS3COOH, and name of this compound is पॅरानायट्रोॲनिलीन. पॅरानायट्रोॲनिलीन म्हणजे आपल्याला जे मिक्सचर मिळत होतं ना, ते मिक्सचर आता काय झालं, संपलं. आता मला 100% हा काय मिळणार आहे, प्रॉडक्ट मिळणार आहे. म्हणजे जिथं मला 51% मिळत होता तोही सेपरेट करून घ्यायला पाहिजे. सेपरेट करताना आणि लॉस होणार, म्हणजे मला 40-45% मिळणार, पण इथं मला काय मिळत आहे, 100% प्रॉडक्ट मिळत आहे. याला काय म्हणतो आपण, प्रोटेक्शन ऑफ फंक्शनल ग्रुप. म्हणजे पहिल्यांदा आपण फंक्शनल ग्रुपची रिॲक्टिव्हिटी काय करतोय, डिक्रीज करतोय, म्हणजे फंक्शनल ग्रुपला प्रोटेक्ट करतोय, आणि नंतर ते प्रोटेक्शन काय करतोय आपण, रिलीज करतोय, आणि आपला ओरिजिनल फंक्शनल ग्रुप काय करतोय, रिस्टोर करतोय. दिस इज नोन ॲज नायट्रेशन ऑफ ॲनिलीन. नायट्रेशन ऑफ aniline. Okay, so this reaction is also interesting and simple reaction. So attacking species is NO2. Attacking species is NO2. Okay, now let us move towards next reaction. That reaction is known as sulfonation reaction. That reaction is known as sulfonation reaction. Okay, so sulfonation of aniline. In sulfonation, SO3H group is attached. SO3H group is attached. So sulfonation also takes place in presence of concentrated H2SO4. Concentrated H2SO4. So this reaction is known as sulfonation. Sulfonation of aniline. Okay, so in this reaction concentrated H2SO4 is used. Concentrated H2SO4 is used to protect the functional group. Now NH2 is basic, means it is base, and this is acid. So what happens, acid and base comes to closer to each other, then what is formed, then salt is formed. Means acid captures H plus ions. Acid captures and base captures H plus ions, and acid donates H plus ions. Okay, so this base captures H plus ions, means NH2 gets converted into NH3 plus. NH3 plus. Now hydrogen is lost, so H2SO4 is converted into HSO4, and this oxygen carries negative charge. Oxygen carries negative charge. So what is this? This is anilinium hydrogen sulfate. Anilinium hydrogen sulfate. Anilinium hydrogen sulfate. Okay, so this anilinium hydrogen sulfate again reacts with concentrated H2SO4, but at higher temperature 453 to 473 Kelvin. 453 to 473 Kelvin. Then what happens? Okay, here NH3 plus HSO4 minus. Okay, here SO3 is attached. SO3 is attached. Now on hydrolysis, this protection is removed. On hydrolysis, this protection is removed, and here NH2 is formed. Here SO3H is formed. So name is parasulfonyl. Name is parasulfonyl aniline. Parasulfonyl aniline. This is the name. Okay. Now sometimes this hydrogen is shifted towards this nitrogen. So what happens here? NH2 gets converted into NH3 and nitrogen carries positive charge. And here what is remaining? SO3 minus. So this molecule, sorry, this ion is known as Zwitter ion because it carries positive and negative charges. Positive and negative charges. So what is Zwitter ion? Zwitter ion is the compound in which two functional groups are present and two functional groups carries positive and negative charges, and hydrogen is shifted from one functional group to the another functional group. Okay, so this is known as sulfonation of aniline. Sulfonation of aniline.